Hey guys, today we're going to be talking about databases inside of Python and how you can use Python to access databases. Now, databases are a ubiquitous topic when we talk about programming. Now, programming, as we've looked at it so far, has primarily been dealing with code inside of Python and how you can use that for different kinds of things. We've looked at how you can store data as well inside of text files and using serialization and things like that. But with databases, we're talking about storing data outside of our program and doing it in such a way that we can filter data, we can search for things, that we can update records, and these kinds of things that we can do inside of databases. So this is a very dynamic way of storing data. And when we get to it, I think you'll see how dynamic this can be, because it's a lot more sophisticated than simply writing something to a text file. And databases are one of those topics that are almost ubiquitous to programming as well. If you ever go into a job as a developer, it's going to be assumed that you understand databases at some level. And even if you're not going to be doing it for a job, understanding how databases work at some level is going to be important for getting data out of systems, because inevitably most everything is going to be stored in some kind of database. And when we do things like programming mobile apps or websites, these almost always use databases. And even games, like most people wouldn't think about databases being associated with games, but games by and large still use databases to store data at some level in the game, especially online games. So if you can think about your high scores or your inventory for your character or your customizations that you have for your vehicle if it's a racing game, all that kind of data is stored inside of databases somewhere on a server. We're going to be primarily looking at this from the context of programming it on our local desktops and using a single user database. But databases, again, are a broad topic, and we're going to hit the highlights of this. So let's dive right in and kind of look at what is a database, how is it structured, and then we're going to look at how I can access data in that database using Python and some other tools with it. So what is a database anyways? As I've talked about, it's a system for storing organized data, and that's a loose definition that could be interpreted in a number of ways, but we are going to be working with a particular kind of database today that generally represents the lion's share of the kind of databases that do exist. Now, a database does several things. It organizes data, and that's one thing that we're going to look at in a slide in just a moment and how that works. But one thing that it also does is it provides data consistency. Now, data consistency is a big deal in databases. The reason why we want consistency in our database is to ensure that whenever I'm writing something to a file, or I'm deleting something, or I'm updating it, nobody else can work with that same data, or make sure that if I'm reading from a given record, I'm going to be able to read that entire record in a database before somebody else updates it, so I don't get these partial reads that are corrupted, or if I'm trying to update data and then somebody else is trying to delete it at the same time, I don't end up getting a partially updated record and then getting delete and thinking that I've actually updated that record. So the idea of having consistency in our database is basically about managing multiple users accessing the same piece of data at the same time, and actually preventing that from happening, so that whenever that particular transaction, as we like to call it in database speak, is happening, it has a consistent write or read experience from that data. And this is important in databases. It's generally not a big deal when we're talking about single user databases, which is what we're going to be dealing with pretty much today. But when we start talking about multiple user databases, that becomes a problem, and we have to be able to manage that. And that's what databases are partially responsible for. But even in a single user database, there is still some semblance of that provides consistency in our database. I'm not going to dwell on that. I just want you to hear that I'm talking about consistency in the context of databases, because it's an incredibly important concept if you go into doing database development. It's not something that you kind of have to worry about, but it's just something that a database does for you. A database also controls security into your database. This is not a big deal for single user databases like we're going to be working with today, but in multi-user databases that are accessed over a network, this can be a big deal, and we want to manage security. And the security is basically who can read what data, who can change what data, who can remove what data, who can add new data, and that kind of thing. So we're really just trying to manage the access to data with our database software, whatever that might be. But for today, we're not going to be worrying about consistency and security a whole lot. We're mostly going to be worried about organizing data, accessing that data, and those kinds of things. But these are very important concepts when we start talking about databases in a broader scheme. I just want to make sure that you're hearing me say something about these. I'm not ignoring these topics. It's just kind of out of scope of what we're going to be talking about today inside of Python. Now, when we talk about databases, there's a lot of ways to store data, and the a method that a database employs is called a paradigm. And the database paradigm that is most widely used in database technology today is called a relational database. There are other ways to do it, and I'm not going to be able to do justice for those. There is literally probably dozens of different paradigms for storing data. My primary concern for today, though, is talking about relational databases and how these work, because, as I said, these are primarily the kind of databases that you'll encounter as a coder. In fact, I probably work with these probably 95% of the time and worked with other paradigms 5% of the time. So there's a lot of different ways to do this, but this one is going to be the most popular. That is a relational database. So data in a database and a relational database really is stored in something called a table. And a table is composed of a set of columns and rows. So if I think about a table, it looks something like an Excel spreadsheet. So I have a set of columns that go across the top and a set of rows that go from top to bottom on. And a column would be something like a name, an address, a city, a state, if I was talking about an address table. And the records or the rows in that table would be a combination of those given columns. So my record inside of an address table would be my name, Blaze, my city, Matthews, my state, North Carolina, and so on. And these individual records are broken down into individual fields, which are the cross section of a column and a row. So the field for name would be under the name column in the record for the individual row that I'm talking about in my given table. So this is one of those things I can show it to you. It's probably going to make more sense as I do that. But understand that we're really talking about tables whenever we are talking about relational databases. Now, other databases store different things differently, but this, for our purposes today, this is how we're going to be organizing our data, is in tables using columns and rows. And then once we have our columns and rows, we can relate these particular kinds of data to one another using something called keys. And a key is usually an ID inside of a table that's usually numbered, like it's a number for each row in that given table, and it's usually just sequential. And if I add a new record to that row, it gets a new number, and so it'll just keep adding new numbers until I run out of drive space or run out of numbers to add. So the idea that I have a key that uniquely identifies that record, then I can use that key and store it in another table, and that other table will have a pointer into my address table. If I have an address ID, I can take that address ID and store it in, say, a person table, and then I have an address ID that points back to the address table that tells me what address is associated with a given person or something like that. So the ability to relate data using IDs and then being able to store data in tables gives us a relational database that we can use for storing all kinds of data. Now, this is optimized for some kinds of workloads, and it's not going to be very conducive for other ones. But for the most part, generally speaking, relational databases are going to be the default kind of databases that most people use, because they are, generally speaking, easier to understand, easier to manage, and can be a lot faster than other paradigms. But that doesn't mean they're going to be the best choice in every situation. And there are cases where other paradigms do make sense. But for our purposes today, we're talking about relational databases. The database system that we're going to be working with today is called SQLite, or SQLite, as some people call it. And this is a very popular database that is used widely inside of browsers and on smartphones and on some desktop applications for storing data. And it's a very lightweight database that's good for also learning how to use databases as well. So the tool that I'm going to be using today is called SQLite browser, DB browser for SQLite. You can go to SQLitebrowser.org and get this tool. So you can go over here to the download page and download it for your platform. So you could download it for Linux, Windows, or Mac OS, depending on which one you're using. And then you can use this utility to actually browse a database. That is, you can open up the database and see the tables that exist in that database. So let's open up a database using this tool, because I've already got it installed, and we'll take a peek at the database that I'm using for our samples today. I'm going to run through this setup because there is one caveat of installing this utility that I found whenever I ran through it that might trip you up if it doesn't show up on your start menu. So when you download this for Windows, you want to run through this utility here for setting up this particular app. So you're going to set the license here. Make sure that you check not desktop, program menu for SQLite browser. This other one, we're not going to be using it today. We're mostly going to be using this utility here. So make sure that you install DB browser for SQLite. You can put a desktop icon if you want, but make sure you put one on the program menu. And then whenever you do that, click next, and then install this, and that way it will get your app installed correctly so you can use it for browsing, and you can actually find it on your programs menu as well. Okay, I'm here inside of DB browser for SQLite. Now, I'm not going to go into the weeds and give you a full tour of this application. I just want to show you the database that we're going to be using today and pull up a table to show you the columns and rows in that table. Now, for most of the demos I'm going to be working with today, I'm going to be working with this artist table because it's a fairly straightforward table. So this shows me all the tables that I have inside of my database here. These are indexes. We're not going to get into that. And there's some other things that we can have here called triggers and views. I'm not going to get into any of that today too, but we're primarily going to be concerned about the tables inside of this given database. Now, if I wanted to look at one of these, I can go browse table right here. And this is going to show me the table itself. It's going to show me the columns that I have. And this is these right up here are the columns that I have. And I'm sorting it by columns right here. So this is my album ID, which also happens to be the key for this table. So this is one column. This right here is a record. So this right here is one record made up of 3 columns, and each one of these various rectangles here is called a field. So the intersection of this record and this column gives me a field. And this is the key for this record. So 1 is the key for this one, 2 is the key for this one, 3 is the key for that one. And this is a piece of data. It's string data. It's a title. And this right here is a key, but it's not the key for this record. This is what we call a foreign key. This is pointing to another table. And this is how we build relationships inside of a relational database, is using the idea of a foreign key, which is going to be the key on another table. In this case, our key is to this table right here, which is the artist table. And so this one has only 2 columns in it. It's got an artist ID and the name of the artist, or the name field. And the name field for this particular record is AC/DC, and the key is 1. The key for this particular record is 2, and the name is accept. So on and so forth. That is the idea of a table, and the relationship to another table is the keys that exist in one table that will show up as the key in another table. So again, just to rehash what we just talked about, I had my album table here, and then I had my artist table here. The artist ID is a foreign key in this table, but it is the key for this artist table, or sometimes called the primary key for this artist table. So this table is related to this table by way of those keys. And those tables are how I store data, and then I build the relationships based on keys. So that's a fairly straightforward concept, nothing too fancy going on there. Now I'm going to pull up a slide that shows you the relationships between all of these tables, and then show you how you can interpret a schema, which is really the representation of the database without the actual records represented. It's just going to show you a bunch of rectangles on a screen, and then it's going to show you how all the different tables relate to one another using keys. So this view of a database is called a schema. Now this shows me the way that tables in my database are related to one another. Now when we looked at the app a second ago, we were looking at the individual tables and looking at the data. This doesn't give me the data in the tables. It just shows me how the data is organized and how it relates to one another. So in this view, we have our artist table, which we just saw a minute ago, and that's right here. And we have our album one that we saw right here. And we have this relationship that's represented by this icon that's a key right here, and then this infinity sign that represents that I have an artist that can have 1 to infinitely many albums associated with that artist. So that's what we call a 1-to-many relationship in database speak. So there's my artist ID, which is the key on this database, which is denoted by the key right there. And this one has the album ID key right there, but notice it's got the artist ID inside of its field right here. And then that just points back to this artist ID right here. So this is how I relate my albums back to my artists. Similarly, over here on tracks, notice I have a album ID right here, And that just simply points back to the album ID right here. And that's how I can relate tracks to an album. And then this track ID has its own key. And notice what this does though, what I can do right here. I can create playlist from different tracks. So I have a track ID right here, right there. And then that's just a pointer back to this track ID. And then I have a playlist ID, which then can be related by way of a playlist. So an album can have multiple tracks on it, and I have one to many between tracks. And then I have tracks that can show up inside of multiple playlists. So I have one to many playlist tracks right here, and then a playlist can have a bunch of different tracks on it. So this gives me different kind of relationships that I might have for these kinds of different relationships that I have inside of this Chinook database that we are looking at here. So the main thing to consider here though is that I have relationships between different tables by way of IDs, and then the fields themselves are going to be various kinds of data. It can be string data, it can be something like bytes, that would be some kind of numeric data, or milliseconds, that would be some kind of numeric data, price would be some kind of numeric data. But you can have different kinds of data inside of your database, but then it's all tied together by different IDs. And this is a very common way of organizing data in something that allows us to manage this data. So now that we kind of have the idea of a database under our belt, I know this is kind of a little bit to take in. It's really not complicated, but it's got a lot of different pieces and can be a little bit daunting if you've never worked with it before. But once you get your head around it, it's really not that hard. Let's go over to Python and let's hook up Python to a database, and let's see how that we can use code to manipulate the data in our Chinook database, maybe add an artist or maybe an album or something like that using code in Python. So to manipulate data with Python, we need some kind of tool to do that with. And the tool that is universally accepted for working with relational databases is called SQL or SQL. If you want to use a phoneticized version of SQL, just say SQL. It seems to roll off the tongue a little better. And SQL stands for Structured Query Language. Now, Structured Query Language is a language that's specifically designed for implementing and managing relational databases like we've talked about thus far. And it is widely accepted across multiple database technologies. So whether you're working with SQLite like we're working with today, or you're working with some enterprise class data system that is in a data center that serves at literally millions and millions of users per second, they all use some dialect of SQL. Now, dialect is basically some kind of implementation of structured query language that has idiosyncrasies about it that are particular to a given database technology. But the principles that we're going to be talking about today can be used across any database that is a relational database that implements SQL. So by and large, SQL is widely adopted and basically ubiquitous to everything in relational databases that we're going to be talking about. SQLite just happens to be the most popular one because it is used widely on smartphones and in internet browsers and on some servers, but other databases like SQL Server or MySQL or Oracle all use this same language as well. They just use a different dialect of it. So let's go look at some examples of this. But first, let's talk about some of the major verbs, if you will, or some of the major commands that this language supports that we can implement in Python to get data and manipulate data inside of our programs. There are 4 basic commands that we can use to manipulate data, and these encapsulate pretty much anything you could do with data that is going to be at the table level. Now, there's other commands for a variety of different things, and I'm going to be talking about the 4 most fundamental commands that SQL implements. And the first one is select, and this is used for reading data. So I can select data from a table or multiple tables using select really, but we're going to be looking at a single table today, and I can read data using the select command, and then I can apply a filter to that data, and then I can get out specific rows based on a filter that I'm using inside of my select command. Similar to a select command, I can also update data. Update allows me to take existing data in my database or my data table and update it. I can change the values of the fields using an update command, and I can apply filters about what I want to update. So if I want to update a set of records or a single record, I can simply just apply a filter and say update data where a given filter matches. And whenever that match returns, I can get and update and apply that to given fields in a given data table, which we'll look at an example of that in a minute. Insert allows me to add new data. So this is the command I'm going to be using to add new data to the bottom of the table. And so this is a little bit different than updates because I don't need to do a filter to add new data. I just need to tell it what the new data is. And so that's what insert is for. And then lastly, delete. Delete removes data from a table. And in much the same way as select, I can use a filter. So if I want to delete a specific record or a set of records, I just need to create a filter that allows me to filter out the records that I want and then use some kind of command and delete them, update it, or select them. So we're going to be using filters a lot across 3 of these commands, and one of them doesn't require it because it's simply adding new data to the field. So let's go over to Tony finally and look at some examples of how you can implement these commands inside of Python. So here's a piece of code that will access and get data out of a database. I want to walk you through this code. Now, this particular database right here is the Chinook database that we were just looking at inside of DB Browser. So this particular statement right here is what I need to get access to a given library that will allow me to access a given kind of database. So because I'm working with SQLite, I need to get a library that allows me to connect to a SQLite database. If I was working with a different kind of database, I would need a different library for that database. But the principle here is the same regardless of what database technology I'm working with. I need some kind of reference to a library that is written for a given database technology. And this will then allow me to set up the next piece, which is a database connection. Now, every database implements some kind of database connection. So this basically gives me a client to my database. And for our purposes here, we're working with a single database. We're working with a file that is on my local desktop here. I'm not connecting over a network to this database. I'm connecting to a file on my file system. So I don't need to specify a lot of information to this connection here. If I was working with a network connected database such as MySQL or MariaDB or SQL Server from Microsoft or Oracle, I would need something called a connection string, which has a bunch of parameters in it that would tell me where the database server is located, what's its host name or IP address, what's the username, what's the password, and what database am I working with, and some other pieces of data that might be relevant to that particular kind of database that I'm working with. And that sets up a connection to that database, and that specifies the way I'm going to access that data as well as the database itself. Because SQLite stores everything in a single file that is a one file that contains all the tables, I just basically say connect to the file. And a single file can only contain one database in SQLite. So if I wanted another database, I'd have to create a new file for SQLite. But in any case, once I get my connection set up, now I'm ready to actually start doing something with that. So this particular app right here, this little program, is asking for the user to enter an artist. And then what it does down here is after it gets a string, which we've seen this before, we're getting input from the keyboard, it's going to do a select for the input that was entered here. So give me all of the artists that match a filter. So I'm going to select star. That means give me every field, every column that's available in the artist table. So I'm going to select star. So select everything from the artist table where, and this is where I set up my filter, name equals, and then this right here is a pointer to a parameter that I'm passing into this execute command down here. It's got a parent s, which basically says go get me a string, and it's going down here and going the percent artist, and so it's going to get this artist variable and basically insert it right here inside of my string. And then once it builds that string, it will then execute that string against the database. So this is building a SQL command. So we're actually using code to write SQL commands. Then we're going to take those SQL commands and execute them against the database using the execute command that is on the connection that I built up there. So once that executes, it's basically going to go out, read the table, filter out the data where it only matches a given name, and then it's going to then come down here and loop over all of the matches it found. If it finds none, it won't display anything. If it finds more than one, it'll display multiple rows. If it finds a single one, it'll only find a single row. So let's run this little program right here and see what happens. So I'm going to search for AC/DC since I know that one's in there, and it displays a single record for where name is equal to AC/DC. If I was to run this program again with another band, let's say Nickel Creek, which I doubt is in this one, which is one of my favorite bands, it returns nothing because Nickel Creek is not a well-known artist. They are a more obscure artist. I didn't think they would be in this database, so it returns nothing. But if I run this again and I search for some maybe Aerosmith or something like that, if I can spell it right, it didn't spell it right. Let's run that one more time. If I spell Aerosmith right, I think I should get a record back that says Aerosmith. Okay, so that's the third record in this database. Aerosmith is a fairly popular rock band. So I've got AC/DC, and I know that both of those bands are in this based on this filter. Let's change this up just a little bit. I'm going to comment out this this line right here, and I'm going to remove the filter and just do a select star from the database and get every record and every column in that database. So if I run this, it doesn't matter what I type in because it's just going to do a select star on everything in this database, and that printed out every record. There's only about 270 records in this database, but you can see here that I have a bunch of records that are available to me, and I can just do a search across those using a filter. So in most cases, you don't want to bring back everything from the database and then try to sort it out in your code yourself. What you want to do is use SQL commands to filter it out and get back exactly what you need, and then work with that in your code rather than try to select everything and then bring everything back and then filter it out in your code and only use what you need, because the database is going to be a lot closer to the data and it's going to work a lot faster. So let the database engine do the filtering and then let your code do the work on the data. So that's kind of the best practice there. So I'm going to go set this back to the way it was, so that when I submit it up to the repo, it'll be there. So that is using a select statement. So I'm here in another file, and this one is going to do an update. It looks a lot like the one that we just looked at. I don't have the comments in this one. I have my import SQLite 3 for my library. There's the connection, so I still need the connection here. I have another prompt for an artist name, but what I have here is a new connection execute. And this one has inside of it update. So I'm going to update artist. I'm going to update the artist table, and I'm going to set some value. I'm going to set name, that is the name field inside of a given record, to S, where, and this is a filter that I'm applying to my update. So if I just applied update without the filter, it'll update every record in the database. That's not what I want to do. So I want to make sure that I do a filter. I've got it hard coded right here for record 76. Let's change record number 1 right here. So I'm going to change the first record in that database. And let's say I'm going to set this artist equal artist where artist ID equals 1. I'm going to set the name to that new artist name that I enter. So let's run this and let's change it. So let's do new artist name, Blaze. And it runs that command, con.execute, there's no output here, and then it does a commit that basically saves everything, and then I close the connection. It's important that you commit data, otherwise it won't save it, and it's important to close the connection so that you clean up anything that you do whenever you open the connection up here. So these are two important commands, especially when you're changing data or inserting data. So if I'm deleting, updating, or inserting new data, I need a commit and a close. I don't necessarily need those for selects, because selects are just reading data, but anytime I'm changing data, which is pretty much any new data, updated data, or removing data, I need these two commands at the end of my file. So let's go over to my select, and let's see if I can change this program up a little bit to look at that new name and get it out, or I can just use the browser application as well. But I'm going to use this right here to create a new filter right here, I'm going to comment out this right here, and I'm going to change my filter here where let's change this right here to where artist ID equals 1, because this is the converse of what I just did. It's actually reading from the database. If I run that, notice that my record now is 1 Blaze. So I have updated that new data in my database for this particular record right here. So if I was to open that up in the actual app too, I would still see that data change as well. But I'm using code, so I can just change, a single command right here and get back new data. So I'm going to do this to get it back to what it was, and that way when I check it in, everything will be as is. So let's go look at a couple more examples. Let's look at insert and delete. Okay, let's go ahead and insert some new data into this using this little app here. So this one, again, sets up a connection just like we saw before. It's prompting the user to enter a new artist name. Notice that this one is using an insert into command now. Insert into is used to insert new data. It is for new records in this given table. It's not updating existing ones, it's doing inserts into an existing one. And so this one is going to insert into the artist table. This is the field I want to change, and this, or create, and this is a list of values that will go into the fields that I specify inside of these parentheses right here. Now, the number of values right here has to match the number of fields that I have inside of these parentheses right here. If I don't have it, it will cause an error. And the data type will also have to match the columns data type that we talked about, be it a string data or numeric data, whatever it might be. It's got to match for the given data type that I'm going to be passing in. So I'm passing in a string into a string-based column here, so that will work. So if I run this, I'm going to be inserting new data into this particular data table right here. Now, this also allows me to do multiple records at once too. If I want to add a bunch of records in bulk, I can do that, but I'm not doing that in this example. I'm adding a single record. So let's go ahead and run this. I'm going to say my new artist is April, and that's going to create a new record in my database. Let's go over here to this program. And this is my select example, unmodified. I just want to search on that. So let's use search for artist, and let's search for April. So now I have a new record named April, and its ID is 277. That was created by the database. I didn't create that because that's a key. It's just auto incrementing that at the end of the table. So if I was to insert a new record, we would see a new key. So let's add in a new key, record here called Ember, and that's my daughter's name. And let's run this one right here and search for Ember for my new artist. And there is the new record for Ember right there. So I have record 278. That's the ID. I didn't create that. That was assigned to this. And there is the name of the artist, Ember. So that is selecting from this. Delete will allow me to delete data from that same table as well. Again, it's using that where filter like we saw already. So delete from artist where name equals whatever the artist name is. So you got to be careful with this. So I don't want to delete everything. So I need to make sure that I do have a where filter on this. If I said delete from artist without a filter, it's going to delete everything in the table. So definitely want to make sure that I have a where clause on that, and make sure you have a good database backup too, because sometimes you accidentally do things you don't intend to. So delete our artist. I'm going to say Ember, and that one has been deleted. So let's go back over here to our select, and let's see if we can search for Ember now, and I probably won't get anything. There's no records there. April should still be there though. Let's run that script one more time, and let's look for April. April should still be in there. April's still in there. So let's go over here and delete April now, and let's run this one more time. Delete artist April. And now let's come back over here to select, and let's run this one. And let's see, search for artist. Let's see if April's in there anymore. So April's gone as well. So I deleted those two records that I added to the table. Now, some things about deleting records. If you try to delete records that have foreign keys in other tables, it won't let you, because it's going to violate that foreign key constraint. That's called a constraint. It won't let you delete data from a table until all the foreign keys in other tables pointing to that record have been removed. Because if you don't do that, what you're going to end up doing is creating a database that has a bunch of records in it that have orphaned keys, as we call them. So those keys don't point to any data that exists. So you have to maintain that data and keep it in good shape. And that's what databases are designed in part to do, among many other things that we've talked about. So we've looked at selects, updates, inserts, and deletes for our given apps that we're going to be talking about today. So let's go over to the challenge and take a look at how we're going to be using these in the challenge. And I want you to keep these in mind whenever we discuss the challenge, and we'll walk through what I want you to do with these commands inside of the challenge when we go to that slide. So for the challenge this week, I want you to use Tony to create a program that implements select, update, delete, and inserts for the genre table. Now, we looked at the tables already. We looked at the database structures using the DB browser program, and you can go in there and you can browse the genre table and look at that table and kind of figure out what's in that table. I want you to create a single program though. I don't want 4 different files. I want a single file that has select, update, deletes, and inserts in that single file that does stuff to the genre table. So basically you're only going to need one connection, and you'll make sure you want to do your commits and your closes on the changes that you make to that genre table. In any case, you want to make sure that you're doing some things on that table that are meaningful, but at the same time, don't beat yourself up if you can't figure out what's going on with it, because it might do some things like try to preserve foreign keys. If you try to delete a record in the genre table that has a foreign key in another table or something like that. So I'm looking forward to your submissions in this particular challenge. It might be a little bit of work to get this into work, but I think it'll be a fun challenge to try to figure out how to write Python that generates the SQL commands to manipulate a database. And as always, you can find the code samples that we looked at in today's video at the URL here, www.github.com/theonemule/ce2c, as well as the sample database that we looked at. So you can download that database and then connect it up to your browser for your DB, or you can use it inside of your code as well. So make sure that you download that database if you don't want to build one from scratch. You're welcome to do that if you want to, but in any case, that database will be there for you to use, look at, and manipulate for your challenge this week. So looking forward to those challenge submissions. And next week, we're going to be looking at some cool stuff related to web-based technologies and how you can use Python to create web pages. So for the challenge this week, I want you to use Tony to create a program that implements select, update, delete, and inserts for the genre table. Now, we looked at the tables already. We looked at the database structures using the DB browser program, and you can go in there and you can browse the genre table and look at that table and kind of figure out what's in that table. I want you to create a single program though. I don't want 4 different files. I want a single file that has select, update, deletes, and inserts in that single file that does stuff to the genre table. So basically you're only going to need one connection, and you'll make sure you want to do your commits and your closes on the changes that you make to that genre table. In any case, you want to make sure that you're doing some things on that table that are meaningful, but at the same time, don't beat yourself up if you can't figure out what's going on with it, because it might do some things like try to preserve foreign keys. If you try to delete a record in the genre table that has a foreign key in another table or something like that. So I'm looking forward to your submissions in this particular challenge. It might be a little bit of work to get this into work, but I think it'll be a fun challenge to try to figure out how to write Python that generates the SQL commands to manipulate a database. And as always, you can find the code samples that we looked at in today's video at the URL here, www.github.com/theonemule/ce2c, as well as the sample database that we looked at. So you can download that database and then connect it up to your browser for your DB, or you can use it inside of your code as well. So make sure that you download that database if you don't want to build one from scratch. You're welcome to do that if you want to, but in any case, that database will be there for you to use, look at, and manipulate for your challenge this week. So looking forward to those challenge submissions. And next week, we're going to be looking at some cool stuff related to web-based technologies and how you can use Python to create web pages. If you like this content, please consider liking this video, then clicking on the subscribe button to subscribe to our channel, then clicking on the bell notification icon and selecting all so that you'll get notifications when new content becomes available on our channel. You can also click on the share icon and share this video to any of your social media platforms. Sharing this helps make it more widely available for those who might be interested in coding. Also, consider following us on Twitter so you can see updates on Twitter whenever new content becomes available, as well as other announcements related to Cool Enough to Code. You can also help us out by becoming a patron on our page by going to our Patreon page at patreon.com/coolenoughToCode and then clicking on Become a Patron. And there you can find out more information about how you can support our work with Cool Enough to Code. And like always, you can check us out online at coolenoughToCode.com. There you can find a schedule of all of the upcoming lessons that we have. You can also find out more information and reach out to us online here. And you can also watch the live stream as it comes out each week on coolenoughToCode.com as well. And like always, thanks for watching this lesson on Cool Enough to Code.